Every day in which you use an iPhone for more than a few minutes, you end up using a table view control somewhere. They're a classic iOS user interface control, and the first complex control we're going to cover. This module explores creating and configuring them, and it will also let us see the importance of delegation over inheritance when programming iOS. I want to stress that what we're about to cover is not just useful by itself. Now, it is useful, really useful, but it's also kind of like learning to drive. If you learn to drive in a Hyundai, you can take those skills into driving a Ford or a Toyota. And if you learn how to drive a manual transmission, then getting into an automatic is easy. Well, in the world of iOS controls, the table view control kinda has a manual transmission. This doesn't just work. There's a lot that we need to do with it before it starts moving. But if you know how to use this one and how to extend it, all the others are like driving an automatic. Okay, that's a heavy analogy. So let me show you. We've been using all these labels with explicit values. Now, sure, we could connect all of them as independent, separate outlets and then start to set each one's text from within Swift. But, as you might expect, there are more substantial controls in iOS, controls that are designed to be filled with data, and that data is going to come from our code. These controls include things like the picker view, which you can find here in the object library, but also the table view. The table view is perhaps the classic iOS data-driven control, and you can't avoid this. When you see an iOS app showing a scrolling list of elements, it's a table view. If you're in the Settings app, you're looking at a table view. You're in the Music app, it's a table view. The App Store itself uses multiple table views. The Health app, the Mail application, Reminders, the Clock app, all of these use table views as either all or part of their user interface. And here's the core ideas when using one. First, let me get a couple of common misconceptions out of the way. When you hear the word table, don't think databases. Table in this context does not mean database table. And related to that, keep in mind that a table view is a view object, meaning this is a way to present data to a user. It doesn't take care of storing or saving anything. That's your job. This is all about making things visible. And we usually think about a table having rows and columns. Well, it's easier here. We don't have to think about columns because an iOS table view is always one column wide. End of story. It'll be one column with multiple rows. And each row, whether that's 1 row, 5 rows, 100, in this table view contains one cell, and it's the cell that holds the contents for each row. Maybe that cell just contains a label. Maybe that cell contains 2 labels or 3 or 4 labels and an image, but it's one column, multiple rows, and one cell in each row. Although it's always just one column, you can separate the rows into different sections if you need to make some kind of visual distinction between one set of rows and the next set of rows. An example would be here in the Settings application. It is just one table view, but there's different sections with gaps between them and different numbers of rows in each section. Now, sometimes it is just a gap, but you can also provide headings and footers, extra text to explain the differences between the sections. But the real question is, how do we get data into this? Well, at its most basic, its most fundamental, the table view control demands 2 things from us, demands 2 things from our code. At the bare minimum, we need to provide in our code some information about how many rows this table view has, and also what is the contents of the cell for each of those rows, what's in each row. And we provide this information using a protocol. And that can mean a little shift in perspective if you're not used to it. Say we have a standard iOS project and we drop a table view onto our storyboard. Well, we do not then just write code wherever we want to go ahead and push data into that table view. That's not the way this works. Instead, a table view object itself expects to be in charge. It expects to be explicitly connected to a class that will act as its data source. And what that means is that we must write methods with specific names, and then we tell the table view where to look for those methods. So for example, there's a method called number of rows in section that we must provide. This method will be called automatically, and it returns an integer value. How many rows do we have? Now, as we saw, a table view can be split into different sections, so this method can return different numbers of rows for different sections if you have different sections. Now, the other method that's required is called cell for row at index path. This provides the cell contents for each row. And again, this method will be called automatically. This one will be called multiple times based on the number returned from the first method. Now, each time it'll be called with a parameter so that we'll be passed the information. So we can say, give me the cell for the first row, then give me the cell for the second row, and so on. And this method will need to return a cell object, specifically a UI table view cell object. Now, at this point, remembering the names of these methods is not important. It's really just the idea that there's a method to say how many rows does the table view have, and there's another method to say what's in each row. Now, you could write these methods and put them in the viewcontroller.swift file that's already connected to our storyboard, and we could tell the table view to look there, and that's a very common way to do it. Or we could even write a new class in our project and tell it to look there instead. We'll run the app, the table view control is loaded, it'll ask who's my data source, and it goes looking for those exact methods. How many rows do I have? Let's say 6. And then it'll call the other method 6 times, asking for the cell contents for row 0, then row 1, then row 2, then row 3. And the table view will build itself, and it'll handle scrolling and anything else it needs to do. But while those are the first 2 methods we need to provide, how many rows and what's in each row, there are more methods we can add, and often will add for additional functionality. We can provide a specific method to say how many sections this table view has. If we don't provide that method, it'll just assume it's one section. But there are also methods we could provide to say, well, if we have multiple sections, do we have headings or footers on each section? Or other methods to say, what happens when a row is selected? Or do we allow the user to rearrange the rows in this table to drag and drop and move them around? And if so, what happens when they do that? But we're getting ahead of ourselves. I am first going to run through a demo of adding and configuring a table view as simply as possible. When you're creating a new application in Xcode, the iOS project template called Master Detail Application does include a configured table view control, but it comes with a lot of other functionality as well, all mixed up in there. And I want to focus on just the table view right now. So to demo this, I'm going to create a bare bones application, once again using the single view application template. Jump right into the storyboard, and then I'm going to open up the object library and find the table view control. It's worth filtering on the word table here because you will find a few things with that word in them. Particularly, we don't want to confuse the table view and the table view controller. What we want right now is the table view. The controller version of it would add more than we need. It would add an entirely new screen to our application. I just want the table view added to this current screen, so I'll drag it on to my storyboard here. I want to make sure that it's going to take up as much space as possible, so I will just drag this and connect it to the sides, to the bottom of the screen. And I don't want to drag it completely to the top. I would like it just to snap underneath the top layout guide, the imaginary line underneath the battery status bar. To lock this down, I'm then going to go up to the editor menu, come down to Resolve Auto Layout Issues, and add Reset to Suggested Constraints. We don't see anything right now. We don't see any rows. We don't see any cells. This control expects us to point it in the right direction. Remember, we're not writing code to push data into this. Instead, we will explicitly connect it. We point it to where it's going to find specifically named methods. Now, I can point it to the right place using code, but I can also make the connection here in the storyboard. So with the table view selected, I'm going to open up my inspectors. And the one I'm interested in is the very last one here. This is called the Connections Inspector. It has 2 references here, 2 outlets to a data source and a delegate. We're going to talk about both, but the one I'm interested in first is the data source. I can grab this little circle, it turns to a plus button as I mouse over, grab, and you might think I'm going to drag it towards a code file. That's not the way this works. What we need to do is drag it towards the storyboard, and I'm going to highlight the view controller icon in the top menu bar here and let go. Because this view controller icon is the visual representation of how our storyboard is linked to our viewcontroller.swift file. This placeholder at the top represents an instance of our viewcontroller class, or viewcontroller Swift file. I let go. What I'm now going to do with the table view is I will see this connection here. The data source is hooked up to the view controller. This means this table view control will now expect to find its necessary methods in our view controller class. So I'd better go and write them. Jumping over into my viewcontroller.swift file, what I'll now do to make my life a little easier is add something to the class declaration on line 11. This currently is saying I have a class called viewController that inherits from is a type of UI viewController. So I'm inheriting from Apple's built-in UI viewController class. Well, I leave that there, but I'm going to follow that with a comma and then start typing. UI tab, we're going for UI table view. Hit tab again, and if I hit the D after that, I get two options, the UI table view data source and a UI table view delegate. Notice in the pop-up that they say PR at the start. This means these are both protocols. These are lists of methods we can volunteer to support. So I'll hit return to support this UI table view data source. Now, it's not required that I actually write this in the class declaration. I could just write those required methods. But the benefit of writing this protocol name here is that Xcode can now help me write the correctly named methods with the right method signatures and parameter types and return types. Xcode is giving me an error over here because it's saying that if I'm volunteering to be a UI table view data source, if I'm supporting that protocol, there are certain things I'm required to do, and I'm not doing that yet. So I'm not conforming to that protocol properly. Okay, well, we're going to fix that right now. One way I can find out which methods I need to provide is by option clicking the name. So hold down the option key, click UI table view data source. It gives us some information about it, but down at the bottom will be the data source protocol reference. And it's going to show me the list of methods that this protocol contains. Table view : cell for row at index path, number of sections in table view, section index titles for table view. Now, if I flick through all of them, I'll notice that only a couple have this required marker on, this table view : cell for row at index path, but also table view number of rows in section method. These are the two ones that I have to provide. So go back to the class. Inside here, give myself a little bit of space. All these methods began with table view, so just start typing TAB, and we get the code sense here. Table view, the one that I'm going to need here first is number of rows in section. So just hit return, and we'll get that method signature. I can see from the declaration here, this just needs to return an int, and that's all I'm going to do. Return 10. Now, right now, I only want one set of rows. I don't need to have my rows split up into multiple sections. If I did, I would add another method called number of sections. How many sections does this table view have? But if I don't provide that method, it will default to one section, just a whole bunch of rows, one right after the other. And the next method that's required is called table view cell for row at index path. Now notice that as soon as I did that, the error symbol in the gutter went away because these are the two methods that I have to provide to be a data source. So this first method will be called automatically and it'll return the number 10. Because it returns the number 10, this second method here will be called 10 times. Each time it's going to get a parameter of an index path in here. That'll contain an integer representing the section. Well, for us it's only one section, so it'll be section 0, but also the number of the row. 0, then 1, then 2, then 3, and so on. So this is the time I need to create and return a cell object. So I'll begin by creating a new cell object. It is of type UI table view cell. And this cell object contains a text label property. So I'll call it this is.
Alo, alo, nghe ông Vương. Sao? Tài khoản nhầm định. Tài khoản nhầm định, từ từ để anh coi lại cái cột đó đây này. Tài khoản nhầm định. Không, cái cột tài khoản nhầm định em bỏ đi em ơi.
What row this currently is. So we're setting the property of that cell. That text label is officially an optional, but I know it's going to be there, so I'm forcibly unwrapping it. And finally, return that cell object. Hit Command R to run this. And here's my table view. While this is a simple example, this is how we get started. We need to say how many rows are in this table and exactly what is in each cell. When we use a table view, we're actually using a combination of multiple view objects all wrapped up into one. We're using labels, there are container views, we're even using the scroll view that we used in the last module, but it's a lot more convenient than just writing it all ourselves. If we'd like to support more behavior for this table view, for example, what happens when we select a row, and right now that's nothing, I'm going to need to go beyond just connecting it to a data source protocol and also connect to the delegate protocol of a table view. So in the next clip, we're going to take this a little further. We're now going to take our Night Porter task list and make it into a table view, also splitting the different kinds of tasks into different sections on that table view and adding headers for each section. As a starting point, I have created, once again, a new single view application project. Now, right now, the storyboard has nothing on it. The only thing I have done is add a few lines of code to the viewcontroller.swift file to create 3 arrays of strings. One array for daily tasks, one for weekly, and one for 2-week tasks. And I'm using Swift's simple array literal format here. Over to the storyboard and we add the table view. So from the object library, I want the table view here, not the table view controller. And I want to make sure that it's going to take up as much space as possible. Drag it to the edges, and then from the editor menu, I'm going to just say reset to suggested constraints to lock it down there. And with that table view selected, I want to have the last inspector open. That's the top right one, the connections inspector. And I should see both data source and delegate options. I want to make sure I can see the top of the scene here and drag from the data source to the first icon, the view controller, and let go. We now see this connection has been created. I'm saying that my table view should look to my view controller for the expected methods. So I better go and provide them. Jump over into viewcontroller.swift file, and again in the class declaration, I'll volunteer here. I'm actually going to say that yes, we are going to support the UI table view data source. Now, last time I implemented 2 methods. How many rows did it have and what was in each row? This time I'm going to do a few more, but the first new one is the simplest. It's just how many sections do I have? A method called number of sections in table view that returns an int. If you don't implement this method, it's as if you've done it, but you're just saying return 1, but I'm just going to return 3. This method will be called automatically by the table view control. And because I've said it's got 3 sections, it's going to call the next method that I need to add 3 times. And that's the table view number of rows in section. This one has an integer parameter called section. It'll be passed 0, then 1, then 2. And I need to return an integer to say how many rows are in each section. So I'll add a switch statement so I can return a different number based on the section. If it's 0, I'll return the number of items in the daily tasks array because I want that to be first. If it's 1, I'll return the count of the weekly tasks array. If it's 2, I'll return the count of the final array. There's one more thing I need to do because switch statements in Swift must be exhaustive. They must handle all possible options. So even though I believe this section parameter will only ever be 0, 1, or 2, it is an integer, so it could potentially be some different number. So I'm going to add a default case at the end of the switch statement and just return 0 if it was anything else, because without a default case, this switch statement wouldn't compile. Moving on, I'm going to add the next required method to return the cell for each row. That's table view cell for row at index path. And once again, this method is called automatically, asking for the cell contents for each row of each section in turn. I'll create a new cell object, and then I'm going to set up a string variable to hold the current task. I need to do another switch to ask what section we're in using that index path parameter, and then I'm going to return the particular task out of each row based on what section we're in and what row we're in. So if it's the first section, I'm going to return a result from daily tasks. If it's the second section, from weekly tasks. If it's the third, from the 2-week tasks. After the switch is done, I should have some value. I'll use that to set the text label on the cell, and then I'll return the cell. Command R, and we'll test this. Well, this looks okay, but I'd like to have headings for each section because they're all just appearing in one mass here. So back into the code. I'm going to add a new method. Again, using TAB to bring up the table view ones, and I want title for header in section. Once again, just doing a simple switch and just returning a different string based on what section we're currently in. Command R to run this again. And from implementing that new method, we're now generating this header at the top of all of these tasks. So we now have a data-driven table view connected to a data source, conforming to a protocol, and separating our rows into multiple sections. When we implement the Tableview data source protocol, we provide methods, at least 2, but often more, to say what data is in that table view. I'll go to the editor menu here and just temporarily fold or collapse my methods here so we can get a quick overview. I'm implementing 4, so we can say how many sections are in the table view, what number of rows are in each section, give me the cell for each row, and then a title for each of the sections. But while these methods describe the contents of the table view, it doesn't say anything about behavior. What happens when a row is selected? Or can we swipe left to right to delete rows? Or can we rearrange rows? You see, the table view control does support these features. It includes functionality to support all the visual aspects of swiping to delete or selecting or rearranging. It's just that that functionality is turned off by default, because although this can provide the user interface for it, all those behaviors will have an impact on our app and in the data itself. So the question is, if I select a row, should anything happen? In many cases, you might tap a row and move to a different screen, but as I don't yet have any other screens in my app, I wouldn't want the table view to try and do that. Or if I allowed the user to swipe this row here, what would happen to my data behind the scenes? Am I supposed to remove this row from my array? So while there is a lot of functionality in the table view control, it's available, but it's turned off by default and you have to opt into it. And if we want to opt into it, we do it in a very similar way to how we started using the data source. We'll provide specifically named methods to tell the table view we're providing that behavior. And those methods are in the delegate protocol for the table view. There's the data source protocol, which defines methods to handle the data. And then there's a delegate protocol, which defines methods to handle behavior and appearance. That's very common. In fact, it's almost always the case that when you connect a table view data source and implement those methods, you'll also connect a table view delegate and implement that protocol as well. Now, technically, you could point your Tableview's delegate and your Tableview's data source to different places, but it's most common. We're going to put all our behavior in the same place. So there'll be 3 steps to this. In the storyboard, I'll open up the connections inspector, and just as I'd hooked up the data source to the view controller, I will also hook up my delegate to the same view controller. Step 2, over into viewcontroller.swift, and just as I implemented the UI Tableview data source, I'll follow that with another comma, and this time UI Tableview Delegate. In Swift, you can inherit from a single class. I'm inheriting now from UI View Controller, but after the class, there's no limits to the amount of protocols that you can support. You just have to separate them with commas. When I implement this Tableview Delegate protocol, there are no actual required methods. I don't have to do anything else. It's simply up to me which methods I want to support. Well, the question is, what are my options? So if I option click the UI Tableview Delegate entry here, I'll get the pop-up. And if I jump to the UI Tableview Delegate protocol reference, I will get the list of optional methods. And there's a lot more of them here. We have some things that are about appearance, like Tableview height for row at index path that returns a float. We've got ways to control the indentation level. There are methods that will allow us to change the height of a particular heading in a particular section. One of the most common methods to implement as a Tableview delegate is the didSelectRow@IndexPath method here. So I'll jump back into my code. It doesn't matter where in my class to write these methods. I'm going to write them after my data source methods. And just start typing. It'll help me autocomplete. Tableview. And what I'm looking for is didSelect. Now be very careful because there's a very similar one which is didDeselectRow@IndexPath. I'll find didSelectRow@IndexPath. If I implement this, it will be called whenever somebody touches a row, and it'll get an index path parameter that contains the section number and the row number. I'll just add a simple comment, use selected row number indexpath.row in section indexpath.section. Command R to run this. And now when I tap a particular row, I'll get the message pop up in the debug area. I selected row number 3, and again it's 0 base, so 0, 1, 2, 3 in section 0. So we could use this method to prepare to move to another screen. We could be using the selected row to make sure we were getting ready to pass any information we needed from one screen to the next. At the moment, we don't have any other screens, but that's going to change very soon. A lot of success in iOS comes from knowing how to extend what's already there, what's already provided. And the table view is a great example. It's always one column wide, multiple rows with one cell per row. But unless we fuel it with data, the table view isn't going to do anything by itself. And we fuel it by providing a data source, by implementing specifically named methods, and then point our table view at the location of those methods. Tell it where to go to find that code. And this is our first practical use of conforming to a protocol in iOS. A protocol is simply a list of specific methods. In this case, it's the Tableview data source protocol that tells us what we can provide, what methods are required, and what methods are optional. We are providing data here, so the Tableview can look at that code to ask, how many sections do I have? How many rows are in each section? What's the contents for each row? We could provide optional methods to do things like provide headings for different sections of a table view. But it goes beyond data. If we want to customize the behavior of the table view, we support another protocol, the Tableview Delegate protocol, where we have another list of possible methods for us to provide. The data source protocol is all about data. The delegate protocol is all about appearance and behavior, particularly things like what happens when a row is selected. Now in Module 8, we're going to come back to this table view and add even more behavior by implementing more methods of the Tableview delegate. But before we do that, we're going to take our basic application with a single view controller and see what happens when we decide to add more.